Supplemental math videos from Circle Christian School.
Graphing trig functions, sine and cosine. Find the amplitude, which is the scale, the period, the stretch, and its phase shift, the place it starts, to graph a function like we did in the old days. When we're graphing a function like sine or cosine, we're graphing the part of the unit circle. So instead of having your whole numbers, we are actually breaking it up into the values given to us by the length of the circle, the radian. And we can actually do it by radians or by degrees, but 90 degrees represents pi over 2, and 180 is pi, and so forth and so on. And the y value is the value that we get out, of course, as we go around the circle here. The amplitude is the height and the depth, and the period is how many revolutions around. Here are two examples of sine and cosine. Note that sine starts at origin, while cosine is actually starting at y value of 1. A number in front of the trig function is defining the amplitude. How high up and how deep is the pitch or the roll or the oscillation. So if we have a 3 here, given our original one, or the parent function is at 0, 1, 0, negative 1, 0, that all we're doing is just multiplying a 3 to it. And of course, when you get a negative coefficient, we're just flipping it down, doing it backwards. Just don't confuse it with a cosine function here. Notice that it didn't start at the 1 or a negative 1 like a cosine was. It's still starting at origin. We can also graph these by calculator. It's just important to have real good window settings. I like to show both sides of my x-axis on the y here from origin. So generally I'll do a negative 2 pi. You can just do 0 if you want to. And then to 2 pi, or if your period is going to be a little bit longer here, you can adjust it by making it 4 pi, 6 pi, whatever. And then my scale I'm going to do as 90 degrees, working on 90 degrees here, breaking it up. So that would be 2 divided by pi. And depending on what your amplitude is, you can adjust your y values here to reflect, to be able to see it well. The number after sign here before the x is going to tell you the amount, it's going to define the period for you. So it's generally going to be from 0 to some sort of pi. A period has the 4 parts of the unit circle: 90 degree, 180, 270, and 360. It's good to memorize the formula or the form here for what a period is, 2 pi over b. This allows you to be able to find out how far a function is going here. And sometimes what you have to do is adjust the parts inside here, since my period in this particular one is going from 0 to pi, that I have to also do a little bit of adjusting by making half marks in between the pi over 2 and the pi. A regular sine function is going to 2 pi, but if the period is being defined from 0 to pi, we're going to have to split it up equally. Instead of by 90s, we're going to have to split it up by 45s to get that down, up, down, oscillation going here. Okay, so to graph a table here of values, what we do is kind of look at it, what happens first and then what happens second. So I'm going to do what's inside the parentheses first and then do what happens with the trig second. So if we put a 0 here in for the x, we end up with a negative pi over 2. And pi over 2 minus pi over 2 gives us a 0. Pi minus pi over 2 is pi over 2. And 3 pi over 2 minus pi over 2 gives us pi. And 2 pi minus pi over 2 gives us 3 pi over 2. And they're going to look somewhat familiar because it's pretty much what we kind of started with. It's just that the values have something happening to them. And now we're going to do sine the value that we just got inside the parentheses here. You got to be a little careful because we've got this negative here. So sine negative pi over 2, which you can actually do in your calculator, and it gives you a negative 1. And then 0 and 1 and 0 and negative 1, taking us back. A phase shift, a transformation. So with our previous functions, when we added and subtracted to the prevailing operation, that is, that k moves it up and down, and the h on the inside here moves it left or right, what we call a phase shift. So we have this important form for either sine or cosine, that if you have something in front of it, the a, that's going to give you the amplitude. Something in front of the parentheses is going to give you the period, and then inside the parentheses there is going to give you the place that you start, the h. So when we have a phase shift, looking at the basic sine curve here, of course it's going through 0. Well, this is kind of that h thing going on. It's, where are we going to start, right or left? And since this one is starting at pi over 2, just means that we're shifting it over that far and starting there and following our way through whatever the period ended up being here. The way that you find the phase shift is that we have to have a leading coefficient for the x here. And for instance, if we had y equals sine 2x minus pi over 3, that we would have to factor out a 2. That is, we're going to divide everything by a 2. And that's going to result in sine 2 x minus the pi over 6. So looking at this, we see that the amplitude is 1. The period here is 2 pi over b, or over the 2 here. So our period is going to be from 0 to pi. And the phase shift, that means it's going to begin at pi over 6. Okay, we need to be conscious of remembering what every little variable inside here, the a, the b, the c's, pretty much represents. The amplitude is, of course, the absolute value of a. Period is 2 pi over b, and so you're using the b there. And the phase shift is c over b, so the value that's happening there for c. In the previous equation, we had a phase shift of pi over 6. So to be able to break up the chart here, we need to have a common denominator between our usual values here of going from 0 to pi. So between 4 and 2 and 6, our common denominator is going to be 12. So pi over 6 is the same thing as 2 pi over 12. And so now we're just going to make equivalent fractions here. So first one, of course, is going to end up being 0. We're going to multiply a 3 to both of these, so we end up with 3 pi. Multiply a 6, so we get 6 pi up here. Multiply by a 3 again, we get 9 pi over the 12. And for the one here, it's going to be 12 pi over the 12. And that's how we're going to break up the line so that we can actually graph it. Now we can actually add a little twist in here by giving ourselves a k. And that would be something being added to the sine equation. And that's going to give us a vertical shift, meaning not only are we going to start somewhere different on the x here, we can go up or we could go down depending on what the d is. So taking a look at y equals 2/3 cosine x over 2 minus the pi over 4, we're going to have to factor out the 1/2, which is going to give us let me take a look at this and I'm going to go back. Okay, I see what I did. I was showing you the work. And so we end up with the pi over 2 here after we divide out the 1/2. So our amplitude is 2 over 3. Our period is 4 pi. And our phase shift is pi over 2 to the right. And if we had something being added or subtracted to it, we would either go up or down. Okay, now to manually graph the equation that we just had. So it was going all the way to, period went all the way to 4 pi. So I'm going to break it up into pi's here equally. Let's see, so this is going to be 3, 2, 1. Okay, just trying to find a nice increment here. So this is going to be pi. And this is going to be 2 pi. And then 3 pi. Okay, so we see that our shift that's happening in here, our phase shift, is at pi 2. So this is going to be, we're going to have to break this up into even smaller parts because we're actually going to start at pi over 2. And so what we have to do is add a pi over 2 to everybody to get the middle of that. So pi plus a pi over 2 gives us 3 pi over 2. And now 2 pi plus a pi over 2 gives us a 5 pi over 2. You just need to add using a common denominator. And 7 pi over 2, you might see a bit of a pattern here, so it can get kind of quick, actually. And 9 pi over 2. Okay, because it is a cosine function, it's actually going to start at the above here, pi over 2. It's going to work at the intercept here at 3 pi over 2, downward at 5 pi over 2, then the 7 pi over 2, up to the 9 pi over 2. And kiddos, that's how we did it in the old days. Try it on your calculator. The big thing is setting a nice good window so you can see what's happening. And watching things that's with your parentheses. To put it into your calculator, you do have to pretty much make that simplification and find your B and your C and if there's any D's being added to it. All right. Thanks, guys. Bye.